The Oasis of the Seas, the biggest cruise ship in the world and the new flagship of the Royal Caribbean Cruise Line, has started her regular cruises from Fort Lauderdale, Florida in December 2009. Heart of the 220,000-ton beauty pulsate the 6 most modern common rail engines by Wärtsilä, which generate a total of 110 megawatts of electricity that powers everything on the ship, from air conditioning to navigation lights. They move the ship and everything on it: an array of restaurants, a real carousel, surfing simulators, rock climbing walls, and a tropical park, to name a few, at a comfortable cruising speed of 22 knots, and they provide the comfort and luxury on board for the 5,400 passengers and a crew of 3,000. The vessel is also equipped with 4 Wärtsilä bow thrusters, which make her easy to maneuver. The bow thrusters are among the largest in the world. They have a combined power output of 22 megawatts, which, in fact, is more power than on board an ordinary cargo ship altogether. Under construction in Turku, Finland, is the sister ship, the Allure of the Seas, equipped with a similar engine arrangement, due to be delivered in November 2010. Wärtsilä has combined all its ship design units in Norway, Germany, Singapore and Finland into a single entity, Wärtsilä Ship Design. The ability to offer complete ship design services brings the company even closer to its ship owner and shipyard customers at an early stage of concept development. It will also help Wärtsilä to tackle the more stringent environmental and emission regulations in the future. The German unit of Wärtsilä Ship Design is involved in the technical design of the European research vessel Aurora Borealis, a multi-purpose icebreaker, deep-sea drilling and research ship for polar sea conditions. The construction of the ship is scheduled to start in 2012. The Viking Lady, a gas-fueled Norwegian platform supply vessel built in 2009 for the Eidesvik Shipping Company, is claimed to be the cleanest vessel ever. The ship has been designed by Wärtsilä Ship Design. The 4 main generator engines are of type Wärtsilä 6R32DF, fueled under normal circumstances with natural gas, but as dual-fuel engines can also be run on diesel oil. The engines and the power drives of the ship have been supplied by Wärtsilä. A fuel cell power system rated at 320 kilowatts was recently installed on board the Viking Lady, making it the first merchant vessel to test fuel cell technology for auxiliary production of electricity on board. Wärtsilä Norway has developed the necessary power electronics and control systems which connect the fuel cell to the electric grid on the vessel. The aim of the project is to test the suitability of hybrid fuel cell power packs for marine and offshore use, to achieve a significant reduction of CO2 emissions, to improve energy efficiency, and to eliminate the emissions of harmful substances as compared to conventional engine technology. In the first half of 2009, Wärtsilä received orders for 2 new power plants to be constructed in the eastern Mediterranean region. The first one will be situated on the Greek island of Lesvos, and the other one on Cyprus near the town of Larnaca. The local demand for electricity on the Mediterranean islands rises dramatically every year during the tourist season, as the resident population is outnumbered by incoming vacationers. The strict environmental norms of the EU allow only fuels with low sulfur content to be used. The plants will be equipped with a separate nitrogen oxides reduction system for treatment of flue gases. In December, a contract was signed to supply a new power plant of 119 megawatts of electricity to be built on the Greek island of Rhodes. The new facilities will increase Wärtsilä's installed base in the region to over 690 megawatts. Introduction of a reliable source of energy at an affordable price is the key to increased industrial livelihood and accelerated development. Wärtsilä's experiences in Africa in recent years have proven the truthfulness of the argument many times over. Senelec, the national company of Senegal for production and distribution of electricity, ordered their sixth power plant from Wärtsilä on the basis of demonstrated fuel efficiency and availability, short delivery time, and compliance with the strict emission level regulations of the World Bank. The 60-megawatt baseload power plant is situated close to the city and harbour of Dakar and has been in continuous operation since 2006. The power plant is operated and maintained by Wärtsilä according to a 15-year operation and management agreement, the first of its kind with Senelec at the time of signing, but nowadays followed by similar arrangements, says Jean-Philippe Duhamel, plant manager, O&M services for Wärtsilä West Africa. The Sabodala gold deposit in the backlands of Senegal, some 600 kilometers west of Dakar, is rated as one of the largest deposits in the world. An open-pit mine operated by the Australian mining company Mineral Deposits Limited started production in March 2009. The company reports having produced an accumulated 4.6 tons of gold by the end of 2009. The Sabodala mine, the processing plant and a housing area rely on a 30-megawatt 5+1 engine power plant for their energy, delivered by Wärtsilä within a very tight 19 months timeframe. The engines were dismantled in Turkey, converted to run on heavy fuel oil and shipped to Dakar together with 160 containers full of new equipment and components. After less than a year of assembly and installation on site in Sabodala, the plant was up and running. A showcase example of excellent engineering, workmanship and project management, applaud the representatives of Sabodala Gold Mine. The town of Bontang in Indonesia, on the eastern coast of the island of Borneo, is where the first gas cubes complete one-engine power units have been installed. The gas cube is a compact pre-engineered unit, complete with all the necessary auxiliaries and components, including an integrated switchyard. It is fast and easy to install even in areas of no previous infrastructure. The two units, based on Wärtsilä 16-cylinder V34 spark-ignited engines, with a combined output of 14 megawatts, run on natural gas to generate electricity for the national grid. The gas cubes were selected for their high generating efficiency and small environmental footprint. Wärtsilä gas cubes have a closed-circuit cooling system that reduces water consumption to a minimum, making them perfectly suitable for locations where water is scarce. The units were ordered by PT PLN Persero, a long-time customer of Wärtsilä that owns and operates numerous Wärtsilä power plants throughout the Indonesian archipelago. Designed for operation with a minimum staff on site and for easy maintenance, the gas cube plants are ready for flexible modular extension to meet growing power demands. In Qingdao, China, a new low-speed marine engine factory called QMD, jointly owned by Wärtsilä, China Shipbuilding Industry Corporation, and Mitsubishi Heavy Industries, has been inaugurated. The first engine produced at the new factory, a 7-cylinder Wärtsilä RT Flex 60C, passed its factory acceptance test with flying colours. Wärtsilä enjoys a global market share of approximately 50% in electronically controlled, low-speed engines. During the past 2 years, orders for 140 of the company's 82-centimetre bore marine engines have been placed. Just in recent months, orders for a total of 30 new 7-cylinder Wärtsilä RT Flex 82T engines have been received for very large crude carriers and ore carriers to be built by Chinese and Korean shipyards. The engines have been contracted by the licensees of Wärtsilä Corporation. Wärtsilä is a major player with a strong presence on the US energy market with its hundreds of installed power plants throughout the country. Wärtsilä power plants have gained ground on this tough market due to their demonstrated reliability, cost-effectiveness and low environmental impact. They have the quickest start-up time in the industry, and they offer fuel flexibility with multiple fuel options: natural gas, diesel oil and liquid biofuels. With the rapid increase of the share of intermittent renewable energy sources, such as wind and solar power on the US market, there is a growing need for new flexible solutions to generate, to back up, and to stabilize the supply of electricity for continuous baseload generation, as well as for peaking at times of high demand of electricity. In Pearsall, Texas, near San Antonio, the South Texas Electric Cooperative, STEC, is constructing a new power plant to replace their existing old steam turbine plant and to back up the growing wind generation capacity in the region. The new 202-megawatt power plant is equipped with 24 gas-fueled gensets. The replacement of the old steam plant will bring about various beneficial effects for the environment and job safety, as the water usage will drop to almost zero and the use of harmful chemicals for water treatment will become obsolete. The new units feature a selective catalytic reduction system for the control of nitrogen oxides as well. A key decision factor in favour of the Wärtsilä solution was the ability to quickly dispatch the new units in increments that fit the varying load requirements, to keep the units at peak efficiency rather than having to partially load a larger unit where the efficiency might not be as good, explains John Packard, Manager of Generation with STEC.
These flexible units have allowed us to respond to changes in the grid when the wind stops blowing and some of those wind resources are no longer available. Units like these can be started to compensate for the loss of that capacity.
The Plains End plant near Denver, Colorado, owned and operated by an independent power production company, Cogentrix, is one of the world's largest natural gas-fueled power plants that use reciprocating engines. Constructed in 2 phases, the plant is equipped with 34 gensets in all, with a combined maximum capacity of 227 megawatts. The plant was originally intended to satisfy the need for peaking power and to provide ancillary services for Xcel Energy, the local utility operator in the Colorado region. Situated at an altitude of 1.8 kilometers above sea level, under very arid conditions and at relatively high ambient temperatures, the plant is a good example of extreme conditions not having any adverse effect on the output or reliability of the Wärtsilä engines. Aiming at technological leadership, Wärtsilä enhances the business of their customers by providing them with complete life cycle power solutions. Creating better and environmentally compatible technologies, Wärtsilä focuses on the marine and energy markets with products, solutions and services.